Okay, so we're going to continue with our discussion of inverse functions. And we said that with inverse functions that we are basically saying that this particular function is in the form of y equals x squared plus 1. And so if we want to find the inverse means we are going to switch our x and our y. A lot of times we do get kind of slipped up with the f of x being y. The function of x is y. So if we want to find the inverse, this function is slightly different than the linear functions that we looked at in class. We want to find the inverse of this quadratic function. I hope that you realize that it's quadratic because it has the x squared. Then we can come over here and I'm going to switch my x and my y. So that is going to give me x equals y squared plus 1. Now, as we said in class, if we want to graph this, we typically have our functions in the form of y equals. With linear functions, obviously y equals mx plus b, but we would never have a parabola written in this form. We would have our y isolated as well. So in order to isolate this y, we want to get it by itself. The first thing that we're going to do is subtract 1. And so that's going to give me x minus 1 equals y squared. And then in order to get y by itself, if we have a square, the opposite of squaring something is to take the square root. We are going to take the square root of both sides. Now, we hopefully are at the point where we know if we're taking the square root that y is going to equal plus or minus the square root of x minus 1. Now, this is going to be my inverse, and so we typically would write it f to the negative 1 of x is equal to plus or minus the square root of x minus 1. Now, we got to talk about why on earth these functions, what's going on with my parabola. I want to look at my graph. We're going from a parabola type graph to two square root functions. We've actually got f of x, f of x is going to be equal to the positive of the square root of x minus 1, and it's also going to be equal to the negative of the square root of x minus 1. Now, we have already done some graphing of our square root functions, so that is going to be extremely helpful in this process. If we graph our y equals x squared plus 1, we know that that's a parabola, so it's going to be our basic U shape, and it's scooted up 1. You can put this in your calculator and look at your graph, but we're going to go up 1 over 1 and then up 2, 1, 2, 3, 4, but because it's a plus 1, we're actually going up to 5 and 5. So this is my parabola that we'd be graphing. If you remember correctly, if there's a plus 1 and it's not in parentheses being squared, this is a vertical shift of 1. Now, if we want to graph our inverse, the reason that we have one function that is a square root, if you remember correctly, a minus 1 inside our basic square root function is going to shift us to the right one. And our square root function does look like 1, 2, 3, 4, up 2. So our square root function is looking like this. But if we want to do the negative half of it, I probably should have switched those colors. If we want to do the negative half of it, it's a reflection over the x-axis. So we're actually going down and then to 4. So what we said was that if we folded about the line, and let's see, what color do I want to make my line? I did it red in class, but we'll make it purple for right now. If I go down my line of y equals x, we should be able to fold on that line, and our two functions will actually be a reflection across the line y equals x. So what happens here is that if you have a parabola, it actually is not going to allow our inverse to be a function. The way I know this isn't a function is because it doesn't pass the vertical line test. We do not have a vertical line here. Or we do have a vertical line here, which is going to say that this is not a function. So just because you start with a function does not mean that your inverse is also going to be a function. In fact, we can look at different types of functions and try to decide where we normally have, like if we have a linear function, something going like this, it passes the vertical line test. We are not going to ever be able to hit, we are good. We are only going to touch with the vertical line one time. So we know that our function, the vertical line test, this tells us that our purple function is a function. This relationship is a function. So the function, well, we have a function. We're good. However, if we want to know about the inverse, we actually do a horizontal line test because our horizontal line is going to tell us whether or not the inverse is a function. So here we're good. If we run our horizontal line up and down our purple relation, then we only touch one time. So the horizontal line test tells us that the inverse is a function. You can take that into consideration. Now we also can look at like any parabola at all that you have. If I'm just going to sketch a parabola on here. Here's my parabola. I'm going to make it really wide. I'm going to go over like this. We know that this is a function because with our vertical line test, actually I'm just going to go grab this one. Right? We're only touching once. So we're good. The vertical line test says that we have a function. We do have a function. But our horizontal line test actually tells us that we are going to, if you do the inverse of this particular parabola and reflect it about the line y equals x, we are not going to have a function. So does not pass. So the inverse is not a function if it doesn't pass the horizontal line test. If we look, we're going to do a quick word problem, and then if I have a few more minutes, we might go back and do a review of just a couple more problems in determining whether or not two functions are inverses of each other. But if we look at this particular word problem, it says the shoe size for the average U.S. teen or adult male can be determined using this particular function, where x is the length of a foot in measured inches. So x is going to be the length of our foot. M of x then will be our shoe size. It says find the inverse of the function first of all. Well, it's up to you. A lot of people like to use x and y. They want to use y. So if you do want to use y to represent m of x, that will work. And so if we want to find the inverse, that means we are going to have x equals 3y minus 22. From here, we want to get y by itself. It does not make any sense to have a function or a relation in the form of x equals. So in order to isolate this y, we want to box it out and get it by itself. We have to go in the opposite of order of operations. We have a minus 22, so we have to add this 22 over here. So that gives me x plus 22 equals 3y. And then we can divide everything by 3. Now, there are some people who are going to do this. They want to divide by 3. If we have y equals x plus 22 over 3, that will work if you're just trying to find values. But if you wanted to graph this, just a little help. Remember, this just means x divided by 3 plus 22 divided by 3. We can split, but we have to divide both terms by 3. This puts us in our slope-intercept form, which is a little more helpful when we're graphing. Now, here's my inverse. This is telling me now that the inverse of our function is x over 3 plus 22 over 3. For this particular function, it wants us to find the size. If George wears a size 9, how long are his feet? Well, x was the length in a foot, so we have a couple of options. One option is to use this, and we can plug in the size and then solve for x. But if we already have our inverse, we can use our inverse and say if y equals x plus 22 over 3, and we want to plug in that size 9, then that's going to give us 9 plus 22 over 3. Well, 9 plus 22 is 31, if my brain is correct. So that's going to mean that his feet are 10 and 1/3 inches. 10 and 1/3 inches. Now, if you wanted to use your original, m of x equals 3x minus 22, where x is the length of the foot. That means we'd be solving for x, and m of x is his shoe size. If we plug a 9 in here as well, and add the 22, we're going to end up with the same thing because we're still going to have 31 equals 3x and divide both sides by 3 until we get x equal to 31 over 3 or 10 1/3 inches. Now, why would we even care about finding this inverse? Well, if you're doing calculation after calculation after calculation, it would be much easier to find the inverse of the function and just use that to plug in than to have to solve for every single one of them. That's going to make a huge difference in time. All right. The last thing that I was going to do, and I don't have a whole lot of time, is look at one more of these particular functions to determine if it is the inverse or not. So here, if I have f of x equals x squared minus 9, and we want to find out if the inverse is g of x, which is x plus 3. Now, in order to do this, if we know that they are an inverse, then f of g of x and g of f of x will equal 8. If I find f of g of x, meaning I start with x squared minus 9, and then for x squared, I'm going to plug in the x plus 3 and then square that minus 9. The one thing that we are going to make a mistake on is we are going to forget to FOIL. We've talked about this over and over. Some of you may have just said, oh, x squared plus 9 and then minus 9 is going to be the inverse. But here we have to make sure that we have x plus 3 times x plus 3 minus 9, which is x squared plus 3x plus 3x plus 9 minus 9. So it will not be equal to just x. It will be x squared plus 6x. Have a great